Good morning, everybody. So today we're going to talk about foodborne diseases, about disease outbreaks, diseases that are caused by either eating or drinking something. We call them food outbreaks, oral fecal, okay? And these here, we call them common vehicle exposure. And these foodborne diseases, they have a special behavior in that you are exposed to a certain food so that you get the disease, and usually you get them in large numbers. Okay, that's why we call them common vehicle exposure. There is a common vehicle here, which is food. There is a common vehicle here, which is drinks, juice. You drink or you eat, both of them, all they are oral fecal, peros. Okay, so we call them common vehicle exposure. You are exposed to something by eating and drinking. CVE. These here, we have four types of them. Either in a wedding, you are exposed to one food. When somebody invites you to a wedding, how many times do you eat? No, somebody invites you to one time to a wedding, let's say to a party, you eat once. Although you may eat more than one plate, this is considered only once. Okay? So in a wedding, you cannot tell people, I want to have dinner with you and breakfast next morning. No, it's just one time. You come, you eat, maybe you eat two plates, three plates, okay, still considered one time. Okay? So this is called single CVE. Single CVE. See? Single CVE. Okay, so we call this single. You are invited to a certain party, to a certain meal, to a certain wedding, and you eat once. That's single. Okay, or multiple. Maybe somebody invited you to spend a weekend in his house, your friend, somewhere in another city, a weekend in his house. Or you are in one single star hotel, one-star hotel. They say they serve the same food. Yeah. Or your friend served you the same food, dinner, the same food, supper. Yeah. So the same food. So this is multiple exposure. You ate throughout the day more than once that particular food. Okay. And then you have periodic. The disease comes to you and goes, comes and goes. Why? Because you are exposed, but in low doses. You are exposed to the food in low doses. What do I mean? Imagine we have a sewage leakage. There is leakage in the sewage into your water source. Okay? And this leakage is very small. The hole is really small. So that pressure comes and some waste comes out into your water. Then pressure goes, the weed leakage becomes almost zero. So there are intermittent leakage into your source of water. Intermittent, it comes and goes. That's why you get the disease now, it's over, and it comes back again after 1 week or 10 days. We call this periodic, up and down, comes and goes, intermittent exposure. Exposure that is not continuous. On the other hand, if the leakage in the sewage, the hole is very big and the leakage is very large and the contamination is very high, the contamination is really high, then what happens? You will get the CVE continuously. You will never recover from it. All the time you have diarrhea. And not only you, maybe the whole people in the suburb. It's a water source. So we have single exposure, we have multiple exposure, we have periodic, and we have continuous. Okay, this is CVE, common vehicle exposure, or we call them foodborne outbreaks. See, when food is served once, when food is served more than once, this is wedding, this is your friend inviting you, this is leaky sewage pipe, but small hole, and this is a leaky sewage pipe, but large hole. Number 4. Okay. So far, so good. Okay. Then we have single exposure, common vehicle. Let's go to the single exposure, which is you eat food one time. It's most common. Okay. So for this single exposure, where you have been invited, let's say, let's say, Christmas party, or Eid al-Adha party, or a wedding party, or any party you can imagine, any mass, any gathering, and there is food served. And usually in these parties, you have not only one food, you have 5, 6, 7, 10 types of food. You have drinks, you have meat, you have salad, you have fish, you have eggs, you have all of these. One of them usually makes the problem. Usually one makes the problem. This is what we call single exposure. And you eat and you go home. This is most common, single exposure CVE. It's characterized by three things. First, it's explosive. What do I mean explosive? It happens in large numbers at the same time, sudden. Usually in the party, you have, let's say, 100 people. 6 hours from this, let's say you had the lunch at 12 o'clock or 2 o'clock. In the evening, 8 o'clock in the evening, 10 people all together, they started feeling same symptoms: discomfort, abdominal unrest or upset, let's say diarrhea, maybe vomiting, depending on the severity. Yeah. So all of these are foodborne symptoms, foodborne disease symptoms. So 6 people, 7 people, 10 people, 20 people all together. That's what we call it explosives, like a bomb. Yeah, comes all together. Sudden and rapid increase of cases. Then limited. Only the people who were at that party, they got this disease. Yes, only the people at that party got the disease. Very rare that you see somebody from the same symptoms or infected the same disease and was not in the party. Very rare. They are all attending the party. Yeah? So what's common? Were you in the party? Yes. Were you in the party? Yes. And you all had symptoms? Yes. Then there is something wrong with the food. One type of food gave us all these problems. Which one? We make investigation, and we'll talk about this at the end of this lecture, this chapter. Limited. And the third thing is rarely that you, as primary case, you transmit this disease to your family. You were in the party, you got these, let's say, gastroenteritis, you don't pass it to your father or to your brother or to your daughter or to your mother. No. Rarely does this happen. Rarely. Okay. Not understood, but that's what they say. Maybe not enough research. They should do research on this. Yeah, to give us an explanation. The primary case remains as primary. Very rarely you see somebody else. So it's explosive, limited, and untransmittable to somebody else. Okay, we have an example here on the foodborne outbreaks. We have an example. In the book, there are 2 examples. One example is this: a school in China in 2014, acute gastroenteritis. And the same disease happened also in the second example, also in the book, on a cruise ship. You know, a big ship going from Spain to USA. Also, they had the same problem. Let's talk about this one. I used to talk about the ship. This time I will talk about the school in China. The school in China consists of 4 floors, 4-story building, 4 floors. And one day, all of a sudden, they had norovirus among the children. And this norovirus, oral fecal, and it causes AAG, acute gastroenteritis, AGE. Okay. We had 2 peaks. This peak, which started, let's say, 14th of December and ended on, let's say, 21st. During this, we had first, by the way, these here, the dots and the crosses and the lines, they mean the floors. 1st floor, 2nd floor, 3rd floor, 4th floor. If you see here, it started all in which floor? 4th. When? 14th of December. 1 day, no infection. Then 16th, we began to see they began to see the cases. The peak happened when? Around 17th. Yes, around 17th. On the 4th floor, you see, lots of cases. So in total, this peak, in total, 27. How much in floor 4, where it started? For 12 people. 12 people out of 27, almost 50%, almost. Okay. And on the 3rd floor, this area here, we had 9. On the 2nd floor, Do they have anything? Maybe yes. On the second floor here, they have these. One case maybe, or two cases only. Only two cases. On the first floor, they had it, but at the end. So it took time to come. Although we are talking all about days, not months, only days. Okay, so a peak and down. What did they do when they realized this? Because when you have 27 students all together having the same symptoms, there must be something that they all had in common. It was food at that time. Okay, they did two things: quarantine. Maybe they asked the students who were infected to stay at home, and this, or maybe in hospital to be hospitalized until they recover. This or that, and disinfection, which means cleaning, using chlorine, virus chlorine, chlorhexidine, Dettol, this, that, any disinfectant. So they did these two things. What happened after disinfection is that the number of cases did not disappear, still existed, but in smaller amounts. Let's say peak two after the intervention, the first intervention, 12 and 15, not 12 and 9. So they decided, oh, yes, this is a problem. We did all the measures we could, and still we have cases. What should we do? Suspend teaching, close classes, close the school. They closed the school for some time. Still, some existed, maybe at home after 2 days. And then after this, all disappeared. All disappeared. So it only disappeared from the school, minimized after quarantine and disinfection, but disappeared after complete closure of the school. Okay. So this is this is the classic epidemic curve. Starts from 0 and up until it peaks. And then all of a sudden, when you interfere, then things go down. This is the classic epidemic curve. Goes up and down. One peak, one head. Okay. Then we go to the determinants of outbreak. There are two forces in the community, in the population, two forces that start pulling and affecting the outbreaks. These two forces, either immunity or susceptibility. How much you are susceptible, you don't have vaccine, your immune system is low, you were never infected before, so you are susceptible. You are ready to take the disease. Or how much you are immune. Maybe you are young and your immune system is very strong, or you have been vaccinated, or you have been exposed to the disease before, so that when the disease comes next time, it's not that severe. So these two forces, immunity and susceptibility, they keep fighting, and we should have balance between them in the community. These are the two forces. Susceptibility high, outbreak. Immunity high, then no outbreaks. So these are the two forces. There is also another concept which is commonly used in epidemiology and public health and in medicine altogether. It's called herd immunity. What is herd? The word herd, what does it mean? No, herd means a group of animals. You have sheep, herd of sheep. Yes, herd of cows. This is the word. Although it talks about human beings. So when you go back to the dictionary, Webster or Oxford, they will tell you also herd can be used for a group of people. Yes, but mainly the first meaning, it means a group of animals, livestock. Anyhow, this here, herd immunity, in order to explain this, I'll give you an example. If you have a village with 2,000 people, a village with 2,000 people. These 2,000 people, we have all of them were vaccinated against a certain disease. And only 20 out of 2,000, they are not vaccinated. These 20 people, they will be protected how? By herd immunity. So the 1,980 people who are vaccinated and immune, they will protect these 20. Is that they will not infect them, because originally the whole population is immune and vaccinated. And another thing is that the probability of these 20 people meeting each other is very low. 20 only. So 20 in Jenin, what is the probability of them meeting? Very low. Or 20 in Paris, very low. Yes, they might meet, but the probability is really low. If these 20 become 200, what happens to the probability? It will increase and infection will spread. Okay, this is herd immunity. So a group of people, small group of people are protected because the majority of the population is vaccinated. Okay, that's the idea. It depends on the ratio. Usually it should be 5%. But I will show you a table for the threshold that we call this threshold for each disease. Some of them 85, some of them 83, some of them 94, some of them 95. Okay, depends on the disease and how severe and how infectious the disease is, yeah? How infectious the disease is. So due to spread of disease from one person to another until number of immune subject becomes large, yes? So that's what I said. So the likelihood, the probability of these small group of people meeting together is really small. Really small. There is probability, but small. What is the practical aspect of herd immunity? Where do we use herd immunity in medicine? We use it in vaccination. In other words, it's not necessary to vaccinate 100% of the population, all the population, not necessary. You can vaccinate 95% and it's okay. Why? Because these 5%, the remaining 5% are protected by the 95% vaccinated people. That's the practical aspect of the herd immunity in medicine. Okay. This is by the way, this is a concept in epidemiology and a concept in medicine and immunology. Anyhow. Okay. So, does herd immunity apply to all diseases? Certainly not. No. It applies to certain diseases that meet these criteria, prerequisites, or conditions. What are these criteria or prerequisites or conditions? First, single host species. This disease is restricted to man, to human being, not animals. That's first. Second, transmission is direct from host to host, from human to human, man to man, human to human. There is no animal involved in the middle. If there is animal, then there is a problem because the animal is infected and you cannot, especially if it's wild animal or small animal, okay? So there is no reservoir. There are diseases that you need animals. Like echinococcus, you need animal in the middle, 2 animals. Taenia, you need an animal. Leishmania, you need an animal as a reservoir. But some diseases you don't need. It's purely human, okay? Third, infection causes solid lifelong immunity. Some diseases, when you get them, you are immune for the rest of your life until you die. Example, chickenpox. You know chickenpox? Who was infected with chickenpox? Certainly all of you, all of us. Usually you get it when you are young. Yes, young. Rarely when you are adult. And when you are adult, you get it, it becomes very severe. Okay? So, solid lifelong immunity. If the disease doesn't provide this, then herd immunity has no use, useless. Okay? And finally, random meeting, random mixing. So usually, as a human being, you meet daily with 10 people, 20 people, depending. You meet them in the market, you meet them in the school, you meet them in the university, and you meet them during your daily life. This is we call random mixing between the people. Yes? You don't stay at home at all. You stay at home, and then after 2 hours you're at school, after 2 hours you're at university, at the mosque, at the church, at this, there. Yeah? So continuous. Your movement is continuous. And this is the 4th condition or criteria. These 4 conditions, then herd immunity applies. If one of them is not met, then there is no herd immunity. Okay, that's the idea. Prerequisites, conditions, or criteria for herd immunity. Okay, herd immunity and vaccination. As I told you, the main practical aspect and the main implementation of this concept comes in vaccination. So here you need and a vaccination coverage of 94 for very infectious diseases like measles. You need to vaccinate 94% of the people in order to get herd immunity. So herd immunity for high communicable diseases. Diseases that are very infectious, you need a high coverage rate in order to break the cycle of infection, interrupt the cycle of infection or chain of infection. Okay? Here's an example, polio. Yes? Polio. We have two types of vaccines in polio, OPV and IPV. Okay? The OPV, live attenuated. You have the virus, but it's weakened. Yes. In IPV, inactivated, and or it's all it means oral, us, yeah, oral, 2 drops in the mouth. IPV killed, inactivated, it's killed by chemicals, so dead. So these you have nowadays we have usually they give 2, they give this and that. Why? Because usually when you give OPV 2 drops, then you start spreading the virus in the community. But the virus is not active. The virus is very weak, does not cause infection, but it causes immunization. So when you spread it in the community, the number of people vaccinated through you by exposure, by meeting, becomes higher. IPV, no. IPV depends on how much you vaccinate people, the coverage rate. How much you vaccinate. The more you vaccinate, the better it's going to be. Better, but sometimes, you know, they use both. In Palestine, they use both. It can have symptoms. Yes, you can have fever, and sometimes it's not fully attenuated, so it can cause disease, but only 1% or even less. So in USA, look, in USA, between 1958 and 61, that's the example in the book, thousands of cases vaccinated here. You have in 1958, when they gave them IPV, only through coverage, only through vaccination, not by mouth, IPV. They expected the number of cases who had polio to be 12,000, around 12,000 in 1958. And then 1958, 59, 10. Those with polio, 10. Then goes down to 8. Then goes down to 8. That's the expected number. But because they have high coverage of vaccination in the community and herd immunity was there, the real numbers were not 12,000, but look, see, the real number was not 12,000, but 4. The real number here was not 10,000, but 2. Why? Because high coverage rate caused herd immunity. Yes, so this is the idea. They expected 12,000, but in fact, they found F4. Here, 1961, they expected, let's say, 8,000 or 10,000. They only found around 2 or less. Why? Because there is high coverage rate of vaccination. Number of cases actually observed, the blue ones. Why? Reduced by herd immunity. They almost vaccinated most of the people, 98, 97, very high percentage. Okay, so IPV does not spread virus in community like OPV, but instead herd immunity can be attained by high vaccination coverage. If this is the one OPV you are giving only, so you can give maybe half of the population only, and wait until the other half, this half spreads the virus into the other half and gives them immunity. But people will not wait like this, they will give both. Yes. Okay, threshold. What's a threshold? Anybody knows what threshold means? A threshold is a technical word that is used in many fields. Threshold, for instance, the renal threshold, the kidney threshold, is 180 milligram per DL. What does this mean? If you have 180 milligrams of sugar, glucose in your blood, if it's above 180, then you will see it in the urine. Threshold. Threshold means that after a certain point, something will happen. Positive test like CT and real-time PCR, they have CT, threshold cycle. Here we have a threshold. After 90%, for instance, then herd immunity occurs. After 180 milligram of glucose in blood, then you will see it in urine. So threshold is a point after which something happens. Yes. So look at these here. Start with measles down here, 83 to 94. So the higher the infectious, the more transmissible the disease is, yes, you need higher coverage. Pertussis, 92 to 94. Pertussis, yeah. Bordetella pertussis. Rubella, 85. Yeah. Diphtheria, Corynebacterium diphtheriae. Yes, 85. Smallpox, 85. Polio, 86. Mumps, 86. Okay. Now we have another concept in epidemiology and public health and medicine also. It's the incubation period. What's the incubation period? Anybody can tell me? No.
The time for the period virus need to be in the host for the symptoms of the
Very good. So it's time between the entry of the causative agent, bacteria, virus, whatsoever, and then the appearance of the symptoms. And this incubation period, usually it can be days, and it can be months, and it can be years. It can be years, like in rabies. Like rabies. Rabies also it takes 1 year for rabies to appear. Hepatitis B, it might take 6 months. If you get needle break or needle stick, finger break, it might, and the dose is not very high, 6 months to show positive test. Okay. So, and during incubation, person is well with organism is well. It means that person is not showing symptoms during the incubation period. If it's 2 months, you are normal. Nobody will know that you have, even some at the beginning, if you test yourself, you are still negative because the number of viruses beyond detection limit, below. Okay. So presence well with organism, not no organism, with organism replicating. So the organism is inside your cell, the virus inside your cell, it's replicating and replicating and replicating, but still you are normal. Until we reach a critical point, where your body cannot withstand anymore. Your body starts screaming and shouting, I have a problem, in the form of symptoms. So the critical mass, also this is another concept, also used in physics, critical mass for nuclear bomb. When they reach the critical mass, then a nuclear bomb can be manufactured. Here, the critical mass, when you reach this critical mass, your body has to show symptoms, has to, because it's more than it can tolerate, critical mass. So there is replication. And the problem with the incubation period is that in the middle of the incubation period, or let's say the second half of the incubation period, you become infectious. You are normal, not showing symptoms. At the same time, you can infect people. And that's the dangerous thing about incubation period.
incubation period is more infectious than the symptoms.
Yes. And more dangerous because you appear normal. Apparently, you are normal. But when you sit with me and him and her, you infect us. That's the idea. Okay. That's why people might ask us, how long should we isolate somebody from a disease? How long? It should be the duration of incubation. Yes, the incubation period. If you remember in COVID-19, good, very good, Sahar. So during the COVID-19 pandemic, at the beginning, they told us it's 4 weeks. Then they said it's too much. Maybe it's 4 weeks. But then, because they want the workers to come back to work, then they said it's 3 weeks. Then at the end, they said 2 weeks is enough. If you have positive, stay at home 2 weeks and then come back to work. So 2 weeks, maybe it's 4. Usually you should stay during the incubation period, the range, because there is no disease has a definite or precise number. It's a range. So, I mean, you have to be isolated or in quarantine for the incubation period plus little bit of time. If the incubation period is 1 month, maybe you can stay 1 month and a week extra week, so that you can be sure that you are free and you're not infecting people. Exactly. There is no precise incubation period. It's range. Yes, I will show you. Okay. So here, when person is no longer infectious and past the incubation period. So maybe incubation period for COVID-19, if it's 3 weeks or 4 weeks, stay 5 weeks. But sometimes they reduce it so they want you to come back to work as soon as possible. They will not pay for you while you're at home. Maybe. I mean, these things, they come in mind. Incubation period, you have factors dictating how long the incubation period is. Some people, they show it in 3 days, some people 1 week, some people more or less. How and why? Well, we have these 3 factors: critical mass. Critical mass. Sometimes just a small number of virus can show a problem to you, can cause a problem to you. And sometimes you need large amount. Maybe this virus, this strain of virus, this bioviral virus is a variant, or the variance is very low. And the other strain of virus, it has high variance, very pathogenic. So this is critical mass. From the A variant virus, you need large critical mass. For the virulent virus, very hostile, very aggressive, small critical mass. In other words, also you need the site. The site. Did you get it by inhalation? Did you get it eating or oral fecal, or in your blood directly? For instance, if you get the virus, HIV, by blood transfusion, it's all over your body. So you get the incubation period will be very short. Yes, that's very important. So the site, infection site, portal of entry. If you remember in the last lecture, I showed you the portal of entry in the body. And the dose. I mean, the needle stick, the needle. Did it have lots of hepatitis B or just a small amount? If it's a small amount, maybe your immune system can deal with it and you will show no disease. If it's a large amount, then you will get the disease, and the incubation period will be very short. So these here, you have sufficient organism replication to reach the critical mass, site of the body. It goes deep, blood transfusion, blood circulation, or just touching, and dose of infectious of the organism, the bacteria or the virus, the dose. So these 3 things, they dictate how long or the length of your incubation period. Okay, incubation period here. We have a disease. Now, we used to have a pandemic, or we are still in it, maybe at the end of it, SARS-CoV-2. But we have another relative, MERS-CoV. Maybe this was MERS-CoV-1, maybe. Yes, or we had SARS-CoV-1. This is MERS-CoV. It's Middle East Respiratory Syndrome coronavirus. It's a relative of the SARS-CoV-2, relative. And this was first detected in Saudi Arabia and in camels, and then transmitted to human being. And then this disease can be transmitted person to person. Okay? So if you see here, one thing that this was a study, number of cases, 110. If you see at the end of 2013, they had a large peak. Then after this, smaller peak. And then there was a large peak in 2015 at the beginning, with the red one happening in Republic of Korea, South Korea, they mean South Korea here, or Seoul. So large peak, and then went down, and another peak. So you see that this epidemic between 2012, yes, very sporadic cases. If you see here on the line, very sporadic cases, until 2017, what's happening is that it's multiple peaks. This is a peak, this is a peak, this is a peak. It's not like the foodborne disease, single exposure, yes? Common vehicle, single exposure. No, this is not single exposure. Looks like it's multiple exposure, person to person, airborne, meeting people very frequently. So it's happening, it behaves different from the CVE, single exposure, or the food, different. There we have only one peak and down. This one, have a look. Incubation period is 5 to 6 days, which is very short, like a week. Yes. And look, that's a peak, another peak, a third peak, a fourth peak, and so on. So this is not, as I said, this is not the classic. See, this is not the classic. The classic X, the classic is foodborne. This is something else. We call it what? Multimodal or multiple exposure. Look, multimodal epidemic curve, multiple curves, up and down. Because it's not food, it's people meeting each other. Okay, so this is the idea. Maybe, oh, what's this? Incubation period. Look, it's a group of diseases, and diseases have different incubation periods. And diseases do not have precise incubation period. Each disease has different incubation period, different range. If you look at rabies, which is caused by dogs, bite of a dog. It's a rhabdovirus, it's a viral disease. Look, a year. But the blue one is most common. Look at influenza, days. The green is the largest range. The blue is the more precise range, more common. Smallpox. Look at hepatitis B. 80 to 100 days. So you're talking about almost 6 months, 5 months, 6 months. Okay. The largest here is rabies. And you have infectious mononucleosis. Very long. Hepatitis A, oral fecal. It's a form of hepatitis infection, but oral fecal, not like hepatitis B through sexual and blood contact. So these are, well, I can show you a case of rabies. Have you ever seen a case? One case which was published, not published, shown on media in Turkey for a Syrian guy, Syrian patient, and they have hydrophobia. They are afraid from water. Maybe I can show you this. So this patient does not want to drink water because he had hydrophobia, because he was infected with rabies. This is one. And he died in Şanlıurfa. It's a city south of Korea, south of Turkey, excuse me, south of Turkey, close to the border with Syria. Okay, this is it for today. Any questions before we go, ladies and gentlemen? Thank you very much.